Welcome to Hadoop Exam Learning Resources. In this session, we are going to discuss regarding HBase regions and region server, how the data is stored into the HBase region. So these first two topics we'll discuss over here, HBase regions and HBase region server. So let me first start with the HBase with the distributed database. This is HBase. So let me write down the topic over here so we can understand more in detail. HBase as a distributed database, correct? So you must be able to understand what is distributed database. So in frankly speaking, it's your data is stored across the node. Okay, so I'll explain you in detail what does that mean exactly. So this is your computer. So let's say computer means these are the servers actually into the data centers, not normal servers, and your all the data is distributed across the server. So what I would say, like one of the user data record would be might be stored across these machines. So I'll explain you a little bit later, so just wait for some time. So HBase sometimes referred as an Hadoop database. Okay, so let me write down. Yes, this is Hadoop database. Why it is called Hadoop database? Do you know? Uh, what exactly is the reason to be saying is a Hadoop database? Because Hadoop is made of two components. Basically, initially, if you say nowadays Hadoop has quite changed. So like Hadoop is firstly like processing engine. So the processing engines is like where your actual data would be processed, like you can say task tracker and job tracker. So these are the two components which are responsible for processing your data, and second is actually the storage, where your actual file or data would be stored. So these are called HDFS, Hadoop distributed file system, correct? So I want not write there. So Hadoop distributed file system, these two components makes the Hadoop. And now that I mentioned, like HBase is called as a Hadoop database. Why? So let me create another screen here first. Okay, so sorry, this screen is very small. Let me create the bigger one, which would help us. Okay, so why Hadoop, we say it's a sorry, HBase is a Hadoop database? Because HBase is in storage. It's a database. Let's assume it's a database like similar to other database. Right now just assume it. Okay, it has very different database, it is very different database, but underlying system where your data is stored is like underlying storage where actually your physical file is stored. I would say is all files stored on distributed node. So similarly on other nodes. So this distributed node is actually part of the HDFS, Hadoop distributed file system. So that is the reason HBase is called Hadoop database, because your data which is your table, I would say this is your table which stores the data, correct, which actually splitted into the multiple part, and each split go to the particular node on the HDFS file system. These nodes are the computer, actually underlying servers, instances. Okay, commodity hardware, you can say. So if you want to learn more on Hadoop, then just visit the www.hadoopexam.com. so there we have more tutorial on the Hadoop, exactly in detail about the Hadoop. So let's first go through over here. So now all your table would be splitted. How it would be splitted will just know understand in few minutes. So this data would go across and the reason we are saying HBase is a Hadoop database, because the underlying storage is HDFS, which is part of the Hadoop framework. So that's why it is called a Hadoop database. Okay, so theoretically HBase can work on top of any distributed file system. Here we are talking about the HDFS file system. This is distributed file system. Your like the data is distributed file system means your data would be stored across the systems, across the files. Okay, so that's the reason this is also why only HDFS, why not any other distributed file system? There are many file system like S3. This is Amazon Cloud 3 Cloud S3 database, not sorry, file system. There is a Cassandra file system, CDF, CDF, yeah, you can say CDFS, Cassandra file system, which is another NoSQL database underlying. So these all are supported, but frankly speaking, the most of the development regarding the HBase is being done using the HDFS. So many things might not work with the other file system, but it will work, always work with the HDFS. So considering HDFS, so that's the reason it is mainly really tightly, not exactly it's tightly, but it is, I always prefer to use HDFS as an underlying file system for the HBase. It can work with any other database. So let me first explain you a little bit what distributed file system means exactly, so you can get more detail on this. Okay, so what exactly distributed files are? Little bit I explain it. Suppose your file is like data file. This is your table where you have stored the data, correct? This is your table, and the size of this table is 10 terabytes. The huge volume of data. On the Google, you are creating everyday blogs, correct? So all the blogs are stored in this table with the content, username and the content and the other metadata. This all stored in this. Now this 10 terabytes, I would say your machine, one computer, this is your one computer, hard drive is 2 terabyte only, correct? So now how would you store this 10 terabytes of data on single computer? Is it possible? No, it is not possible. So what you will do exactly, you will break this file into the 5 part, into 2 terabytes. So this would become 10 terabytes, correct? So that's the reason you need at least how many computer or commodity server to store this data. At least you need a 5 system to store this data, so 2 terabytes on each server. So Hadoop framework is capable of breaking down this file, storing each 2 terabytes of the file into this 5 computer, and they all can communicate with each other using another node, that is master node. Okay, so that is so that's why your file is distributed across the 5 machines, and this machines are part of your HDFS file system. So distributed file system, so in more detail you have to learn the HDFS to get more detail. So I'm just giving you a little bit explanation what HDFS means exactly and what distributed file. So all the data in HBase, this is your HBase table. You need to store 10 terabytes of HBase table, then you use this 5 computer at least. I'm saying that you need more computer to store this 10 terabytes of data. Okay, so that's what here we mean distributed file system. So your data is distributed. HDFS is inherently scalable. Okay, so you can scale it as much as you want. Is it can support 10,000 nodes, even more are nowadays supported with the Hadoop version 2 onwards. It is like more than 10,000, even 1 lakh nodes in the cluster can be supported. So that is not even enough to scale HBase. HBase has to scale. Even HBase is faster read and write database. Okay, so that's only being an HDFS is not only the is for cause of the scalability. There is other reason as well. HBase has its own implementation of this. Tables in HBase can scale of billions of rows actually, correct? So that's what we mean here. So like your table okay, let me clean out. Okay, so now I would say your HBase table. Okay, now let's enter into the HBase area. This is your HBase table, correct? So now here you can go up to billions of rows in a single tables. What I means, billions of blocks you can store into the single table, millions of columns in single, uh, you can say row, you can have millions of columns. So that is the capability of a HBase table has, which is no RDBMS. RDBMS has, I think, 1,000 columns of limit. You cannot have more than that. There might not be a limit on the rows right now, but yeah, but supporting the billions of rows and millions of columns using in a single table is the beauty of the HBase. Okay, so that the size of each table can run into the terabytes, zettabytes, even petabytes. It depends, like it can increase as much as possible. So that's huge data size in a single table is supported. It is clear that scale that entire table cannot be hosted on a single machine, as we have discussed. Like if it goes to the hundreds of terabytes one table, is it possible? Because my machine capacity is to storing 2 terabytes, so I need at least 50 nodes to store 100 terabytes. Instead, tables are split into the smaller chunks. So now what we have discussed, correct, my table is this huge table would be divided into smaller chunks, correct. So here I have divided into the 50 chunks, correct. My table, each chunks contains 2 terabytes, so my table size is 100 terabyte. Okay, so these chunks are actually called region into the HBase term. This region, this each run. So how many regions are here? So 50 regions. 50 regions are there, and server and machines that host this region are called the region server. Okay, let me go little later on this what region server means. Okay, so the basic unit of scalability and load balancing which help to do this all this thing is the reasons, which will help us to do this all improvement. Okay, they are dynamically split by the system when they become too large. Okay, so now let me tell you, I have 100 terabytes of table. My each chunk is the 2 terabytes. My new row comes into the table, correct. My capacity is 2 terabytes of the chunk. Okay, so this is one of the chunk which is capable of storing 2 terabytes. Now new rows come to add in this. Why in this region right now, forget about this, we'll discuss about this. But yeah, one row comes in, so the size of the region becomes bigger and bigger. If you added thousands more rows to this, in this case, if you add 1,000 more rows, correct, so it becomes bigger and bigger. So what happens, there is a size limit of each region, because you know the system cannot store bigger than one size. So this size is configurable, where we can configure, I'll let you know. So as soon as your size like some configuration value, like this is not in terabyte, generally 100 megabytes or something. So as soon as your chunk size crosses the 100 megabytes, which is configured value, your chunk would be splitted from in between. So there are, suppose, 1,000 rows in this chunk, 500 rows in first chunk and 500 chunks. So it would be splitted into two regions. One region would be divided into the two regions. So this region is actually your actual storage, okay, where data would be stored. They may also be merged to reduce the number of required storage files. So okay, so this is about reducing, but sometimes you might delete the data as well from the table, correct. So in such case, if your regions are becoming smaller and smaller, like because of deletion, so this region can be merged together and can create a bigger one bigger region to be accordingly. So then region can be splitted and region can be merged. The HBase regions are equivalent to range partitions. I don't know you know the database in detail or not, but the range partitions, so okay, I'll not go in detail this. If you understand range partition, so that's good for you. So this is the range equal to the range partition in the RDBMS. Initially this is only one reason. When you first time create a table, suppose first time you define a table to create table or something, some syntax, let's assume it, syntax will be definitely different here, but let's say create table, table name is a user or something. So first time you create a table, so there would be always only one reason for each table. As soon as you insert the data, so the reason becomes like bigger and bigger, and then suppose there is 100 megabyte is the size limit of my reason, and I have added 10,000 rows in this, and it has filled complete 100 megabytes. Now the new row comes next row, and this is 10,001 row. So what it says, like this reason is not crossing the limit. What it does is actually break this reason in between and create two more reason out of this, and the all 5,000 rows would go here and next 5,001 rows go here. So there are two reasons, correct? So and until it comes to the 10,000 row in each reason again, so this two reason would be solved. As soon as the new row comes, then this reason would again be splitted into this two more reason based on the new rows come in. So this way dynamically the reasons would be created from in the HBase table. So this is the way reasons are being created. So reasons are the actual chunks where your data would be stored. This is your data file. As soon as it comes configuration size, okay, so this is what we have discussed. In the row key in the middle of the reason will actually split the each reason is served by the exactly one reason server. What that mean here? Okay, let's assume it what reason server of the computer is exactly the server. So let's assume I have three reason server. So in my cluster, my HBase cluster is made of three nodes. Let's assume it. Three nodes, all three are, I would say, reason server. Why reason server? Because they are capable of storing reason. So the size of the hard disk here is 2 terabyte on each node. So my cluster capacity is 6 terabyte. However, I am not considering here replication factor and many other things. So I'm just considering one as a replication factor. So 6 terabyte is my storage area, and my each reason size is 100 MB. So here we can store almost, I would say, let's say 1 GB store 10, and so 100 and 200 reasons in each machine I can store. 200 reasons I can store. So total 600 reasons can be stored over here in HBase. So as uh, these are the reason server, and exactly one reason is solved by the one reason server. So like your reason would be stored on one of the machines, so it would be replicated, but let's assume it there is a single copy. So this reason, whenever you fetch the data, this reason server will serve to your request by say giving you the data. How this process happens we'll go in detail later session, in detail session. Okay, the reason allows for fast recovery when the server fails or something. So if that is about the availability and failover, we'll not go in detail right now. That server becomes unavailable or something. Okay, so reason server are typically co-located with the HDFS data node. So if you know the HDFS we have discussed about, this is the data node. So in HDFS term, this is a data node, and this is the reason server, you can say. So data node is also storing this data. So these reasons are mostly stored into the data node only. So this would be in most of the cases are the same. So this, because of this, whenever if you run the MapReduce job, and if you wish to run the read the data from HBase, then this reason would be read from the data node. So this would be helpful to you to get the data from that reason server. So this data locality comes into the picture. So the local data would be read first. Reason servers are typically clients and store all access data on HDFS. So reason servers are the client which reads the data from the storage of the data node. So this reason servers are the client for the data node. They will ask, give me the data or store my data. These reasons are the data, correct? So give me my data rows from my reasons. If reason server ask, if or reason server can ask to store this reason to this data node. So this is the client comes somehow. The master process does the distribution of the reason among how it is being in which area reason should go, which node which reason should go. So this kind of information. So there are another tables which actually help you to find the exactly where is the my data into the table. So there are root and one meta table is there which help you to find the data where is located. So this information is stored where is your row, you can find it. So okay, so all the reason servers have access to the same persisted files in the file system. Okay, so these files are accessible for this. By physically co-locating the data nodes and reason server, you can implement the data locality. So reason server then theoretically read and write the local node as primary data node in some deployment. Okay, so now this is about, is there any use of MapReduce? Like a basic question. Suppose I am installing HDFS, sorry, HBase. Do I need to install MapReduce? No, it is not necessarily you have to install the MapReduce at the same time, because HDFS is a storage. If you really want to read process the data using the MapReduce, then you can install the MapReduce framework with that. Otherwise there is no need to read and while reading and writing the data to the reason server, there is no need for this. Okay, so the property which I was talking about, which would help to configure the reason size, is exist in the HBase site.xml file. Correct. In this there is a property called hbase dot hreason dot max dot file size. So this property generally you configure 100, so it's a 100 MB would be would be the capacity. Okay, so for each reason would be at least 100 MB size, and as soon as it crosses the 100 MB size, it would be broken. So that's about the reason and reason server and its splitting. So thanks for watching this session. Exactly, so this session is from the hadoopexam.com. so this is our website. If we go through this is hadoopexam.com. You can just type it over here. So there are various material regarding Hadoop certification, Hadoop training. Soon we are going to launch the HBase training, so you can get it from here. So all the full length training we are going to launch about the HBase, so please visit and you can get more detail about this HBase training. So this is regarding certifications as Hadoop related, and we have cloud related certification as well, data science certification, Amazon Web Service certification, which help you. So just click on the tab and you can get more details. So there are free resources as well available, so you can download the interview questions in the PDF format. You can go to the free tutorials provided, like Kerberos security on the Hadoop, Apache HBase interview questions is also provided here, Flume and many other technologies. So we are keep coming with the new things. And if you are looking for a job regarding the big data, so I would suggest you go to the quicktake.com. This is another website by us. So in this website you can create your own profile. This is mainly for the big data and software professionals, so where we have many companies are posting the jobs over here, and you can even create your own articles, you can create your profiles. And this is so we are implementing this website, many things on this website. So, and one most important things, as you're watching this video on YouTube, so then please do not forget to subscribe this channel, because this we are keep launching the free session as well as the any information session we are doing, so you can get update if you subscribe this. So I would suggest please subscribe this YouTube channel, and you can watch the free sessions as well as paid session if you wish. And various offers are going on, so this information you would be available to you. So please keep watching this and following us on the many other places like Twitter, Facebook, LinkedIn. So these all are is given over here, so to keep in touch. So thanks for watching, and I wish you all the best for your big data career. Thanks.